All right, today we're going to look at how we can solve systems of equations with something called a matrix. Okay, and so we know how to solve systems of linear equations. That's nothing terribly new. And now we're going to use matrix algebra to do this. So let's look at this system here first of all. And here we have a system of linear equations we want to solve. And we're going to go through and use elimination. All right, and so we have, when we use an elimination, we have these two equations. We would like one of these variables, either the x's or the y's, we would like one of those to disappear. But right now, they're not going to disappear. We know that we can add or subtract these equations. And if we add or subtract them right now, they're not going to. So we might say, what do we have to do to make some of the variables match? Well, let's look at the x's here, and let's see if we can make those match. Right now we've got a 3 and a -4, and we would like these guys to be the same. Well, how about we make them equal to 12 and -12, all right? Over here, we're going to have some notation. This is going to be, let's call this E1 for equation 1. Let's call this E2 for equation 2. And we're just going to keep track of what we're doing with these equations. All right? So let's take the first equation and multiply it times 4. And we'll say that's 4 times E1. Well, if we multiply the first equation by 4, we get 12x plus 8y. Got to multiply everything now, right? Equals 24. You know, let's multiply the second equation by 3. 3 times E2. Well, that's going to give us -12x minus 9y equals -21. Keep in mind, we're multiplying everything there by 3. So we took this E2 here. This is our E2. All right? So we took our E2, which was this guy right here, E1, and we did this operation to it. Okay, again, keeping track of our operations. Now we can take those two equations and we can add them. All right? And so let's take these, let's say E1, which our new E1, we can think of it that way, and the new E2. Let's add those two together. Okay? And so we're going to add these. Okay? And we're going to do something that's a little different here. Okay? First of all, I'm going to copy down this equation 1 that we have. We have 12x plus 8y equals 24. We always want to have two equations when we're doing this. You'll see why soon. When we add them, I'm going to write, that's my equation 1 from up above here. Just dropping this thing down here. Okay? And now, if we add the two equations from up above here, we add the x's, we get 0. 0x. If we add the y's, we get 8 plus, we get 8 plus -9 there, and that's going to give us a -1, right? Okay, so it's going to give us -1y. We obviously don't need the 1 there. And then if we add the constants over here, 24 plus -21, that's going to give us 3. Okay? Now I'm going to go ahead and erase the 0x. We don't need it there. Well, change my mind. Let's leave it there. That'll be good. Okay, so we're almost there. Let's go ahead and take the last equation and let's multiply this by 1. -1, actually. Let's take -1 times E2. Okay? This top one, we're just going to copy it down. 12x plus 8y equals 24. And we're going to multiply the second one by -1. We get 0x still. And now we have a plus a 1y equals 3. Well, that's great. We figured out what y is. Okay? We want to figure out what x is. Okay? Now, to do that, what we're going to do, we could plug this back in. We know this tells us that y is 3. We could substitute this. That's an option. Now we're going to do something a little different. And this will help us with our matrices. What we want to do is we want to use elimination again. So I'd like to eliminate this Okay? And so we're going to do two steps here now. Okay? I lost track here, just copying out E1. We're going to take, I'm just going to copy down E2 here. Okay? 0x plus 1y equals 3. Okay? And what I'm going to do now is I'd like the y's to disappear. Here we have the x's disappeared, but I would like these y's to disappear up above here. And so if I can take 8 of these, if I can take the first equation up here, and we can, let's take this first equation, and let's subtract 8 times the second equation, and that will make these y's disappear. Okay? So if we take, let's record what we're going to do here. We're going to take E1 from up above, and we're going to subtract 8 times E2. We're going to do 2 for 1 now. Okay? And what we get, well, we have this 12 minus 8 times 0. 12 minus 8 times 0 is 12x. We have this 8y minus 8 times 1y, and that's going to give us 0 y's. We have this 24 minus 8 times 3, and that gives us 0. All right? So, actually, hold on, something just does not work out here. Made a little mistake. Did you catch it? You're probably watching. Right here, we need to multiply this 3 times negative 1, and that gives us a negative 3. Okay? All right, so let's clean this up a little bit, this negative 3. And so now we have 24. We're doing E minus 8, E1 minus 8, E2. So we have 24 minus 8 times negative 3. Let's write this off to the side. 24 minus 8 times negative 3. Well, that's going to give us, this is a positive 24, so it's 24 plus 24, so that's 48. Okay. 48. Now do some careful arithmetic there. All right, now we're looking pretty good. Okay. This last one down here now, we have y equals 3, and let's take this equation 1, and let's multiply this by 1/12, which is really just the same as dividing by 12. So we divide everything by 12 here, and that gives us 12 divided by 12 is 1x. Okay, and 0 divided by 12 is just 0, and 48 divided by 12 gives us 4. Okay, and so we did this process, and it's kind of a cumbersome with the x's and the y's, but we found out that x is 4 and y is 3. Okay, now we're going to clean that up with matrices. So we'll come back to this table in just a second, but flip the page. And here's the big question we might be asking: what is a matrix? All right. So if we have a system like this, we can take the important information. The important information here is the coefficients. And the coefficients can be written in a rectangular array like this here. Okay. We take our 3 and our 2 and our negative 4 and our negative 3, and we write them here in an array called a matrix. Okay? A matrix has rows and it has columns. This particular matrix here is a 2 by 2. We have 2 rows going this way. Those are 2 rows. And then we have 2 columns going up and down, going this way. Okay? So we call this is a 2 by 2 matrix. Okay? That's called the dimension. The dimension of a matrix is how many rows by how many columns. All right? If we were to take these 2 constants, our constants from up above, we have 6 and negative 7. We can make a small matrix out of those. Okay? And this is our constant matrix. So 6 and negative 7. That's a 2 by 1 matrix because there's 2 rows and 1 column. Now when we're working with systems of equations, we want to do or to use what's called an augmented matrix. An augmented matrix puts those two together and we get this. And this bar right here kind of symbolizes, let's see, this bar in between symbolizes where the equal sign goes, all right? So here we have 3, 2, and 6. That's really just representing 3x plus 2y equals 6. And negative 4x minus 3y equals 7. And that's just our system that we represented above. Okay? And so the whole point of using a matrix is to be able to do the same work that we just did without so much stuff getting in the way, all the letters getting in the way. Okay? And so our goal, we're going to go back and we're going to solve that system with matrices. And our goal here is to get this. We're going to start with the augmented matrix that we have from our system, and we want to get it down to look like this. 1x plus 0y equals, we'll put a star here, some number. Or 0x plus 1y equals a star. Well, that will tell us what x and y are. All right? And so, let's go back, flip the page back now. Okay? And let's do this as a matrix. So we're going to fill in the right 2 columns here. Using the coefficients and the constants, we get this matrix. This is an augmented matrix. And now we're going to call this row 1 and row 2. And remember, they just represent equations. And our goal down here is to end up with an augmented matrix that says 1, 0, and some number over here, 0, 1, and some number over here. And you might have an idea of what we end up with, or where we're headed. Okay? So let's work through it. Okay? Copy this down with us as we go. Well, we want to get down, and keep in mind here, we want this to become a 0 on the bottom left corner. That's what we want. And so we want to, we have some row operations. Okay? Our row operations, flipping back to the other page here. These are what we call our elementary row operations. We can interchange rows. Interchanging rows here, that's just like flipping equations around in our system. We can multiply a row by a non-zero number called a scalar. We can add a constant multiple of one row to another. That will help us cancel out some variables. All right? So these are all just things that we can do with the equations. And so that second one that we said there, we can multiply the row by a number. And so let's take this first row and let's multiply this by 4. And that's going to give us 12, 8, and 4 times 6 is 24. And then we're going to take row 2 from above, and we're going to multiply that by 3. And that gives us negative 4 times 3 is negative 12. Negative 3 times 3 is negative 9. And 3 times 7 is 21. Okay? Oh, we got a little typo here. Well, this is a negative here. So if that's on your handout, if your handout missed that negative, go ahead and add this negative here. It's a negative 7. So it's negative 21. All right. And so we see that these are just the coefficients from over here. 12. Let's try that again. We have 12, 8, and 24. 12, 8, and 24. Negative 12, negative 9, and negative 21. Negative 12, negative 9, negative 21. Okay? So again, it's just another way to keep track of all this information a little nicer. Okay? Let's keep rolling here. Now, if we can add these two. We're going to copy down row 1 exactly as it is, 12, 8, and 24. And then we're going to, in the second row, we're going to add what we're left with when we get row 1 plus row 2. And we add the rows and we get 0. 8 plus negative 9 gives us negative 1. And then we have negative 24 plus negative 21 gives us 3. Okay? And again, you can check over here. It's exactly the same as what we did. All right? Now, we almost have this. We want this to be a positive 1. So let's go ahead and take the second row and multiply it by negative 1. And that's going to give us 0, positive 1, and negative 3. We won't make the same mistake we did. And we'll just copy row 1 down for now. 12, 8, and 24. Okay? Now what we want to do, the second row is just fine. We're going to leave it alone because it already has 0, 1. That's what we want. And we want to take the first row and we want to make this 8 become a 0 because that's our goal down here at the bottom. We need a 0 in that position. We already have a 0 in the bottom left. That's what we want. But we need this 8 here to disappear. And so we can take 8 of the second row and subtract it from the first row. So we take the first row and we're going to subtract 8 times the second row. That's exactly what we did over here. Okay? And so we don't have to mess with the x's and y's. So we take 12 minus 8 times 0, that's just 12. 8 minus 8 times 1, that is 0. 24 minus 8 times negative 3, that's going to give us 48. Okay? And so, oops, lost my, okay, let's back up here. All right, so, wanting to disappear on us. All right, so the idea here is we now have the second row is just fine. Row 2 we're just going to copy. Row 1 we want it to be 1, 0, and we can do that by taking 1/12 times row 1 from above, and we get this. 12 times 1/12 gives us the 1 we're looking for. 0 times 1/12 is 0. 48 times 1/12 gives us 4. Okay? And we remember now all this represents is the equations that says 1x plus 0y's equals 4. In other words, x is 4. 0x's plus 1y is negative 3. And x is, I'm sorry, that's y. Y gives us negative 3. All right, and there's our solutions. Okay. Now you might say, why do we do all that work? Oh my goodness, that's such a pain. Well, here's the deal. This is only a 2-variable system. We could have a 3-variable, 4-variable, or in real life we have hundreds of variables in a system. And it's very cumbersome to deal with all these letters when you have maybe 100 variables. And so matrix algebra helps us to really streamline things. Okay? So, all right, well, that's the steps. Okay? So go ahead and we're going to try these out here. Turn to the third page there. We've got some systems. And for each system, we're going to write it as a matrix. We're going to use the elementary row operations to change it into reduced row echelon form. So once again, our goal is to take this matrix, which is 2, 1, 10. 1 is the coefficient here. Let's try that again. 2, 1, and 10. Okay, using the coefficient there. And 1, negative 2. Make sure you have a little bit of spacing between these numbers. Negative 5. Okay? And so we're going to change this and keep changing it until we end up with 1, 0, 0, 1, and then a couple of numbers over here. And whatever we get, these are your answers. X equals and Y equals. So let's give that a try. Move on through these, and then on the last page there, we'll see how we can use our calculator to find our reduced row echelon form, and all the steps are there. Good luck.